Hi guys, I will explain the moment of inertia, part 2, from second moment of inertia for rectangle to summary. Here I have a quiz for you. There is a rectangular cross-section with its dimension b by h. What is the product moment of area? Number 1, b to the 2, h to the 2 over 4. Number 2, b to the 2, h to the 2 over 12. Number 3, 0. I explained the first moment of area and the introduction of second moment of area in the previous video, E40. In this video, I will explain the second and the product moment of area and the parallel axis theorem for rectangular cross-section. The others will be explained in the upcoming videos. Let's review the steps for calculating the second moment of area. And step 1, we formulate the expression for small area dA parallel to the reference axis. And step 2, we calculate the small second moment of area. And step 3, we integrate the small moment of area obtained from step 2. Parallel axis theorem is very useful to calculate the second moment of area. I will show the derivation of parallel axis theorem. Here we have two coordinate systems, yz and yz prime. They are parallel each other. Yz coordinate has its origin at the centroid. Origin of yz prime locates dy and dz away from that of yz coordinate. From the definition, we can calculate the second moment of area for yz prime coordinate. Y prime equals to y plus dy here. Therefore, we have three integral terms. The middle one equals 0 because first moment of area is 0 when its origin is at the centroid. Consequently, we end up with this equation, which tells us second moment of area in the arbitrary axis can be expressed as the sum of second moment area at the centroid and area multiplied by distance squared from the relevant axis. Similarly, we can derive the equation for the other axis and also for product moment of area. This picture shows the summary of parallel axis theorem. For the distance dz and dy, we have the second moment of area iz prime, iy prime, izy prime. Second moment of area with respect to the given axis is the sum of second moment of area with respect to the axis passing through the centroid parallel to the given axis, and area multiplied by perpendicular distance squared between the axes. Per the product moment of area, distance squared is replaced by product of perpendicular distances between parallel axes. Now, let's calculate the second moment of area, iz prime, for rectangle in two ways. The first way is to calculate it by direct integration. dA is b dy, diz prime is y squared b dy. Finally, we have bh to the 3 over 3. The second way is to calculate it by parallel axis theorem. When we know the second moment of area for the axis parallel to given axis and passing through the centroid. By the parallel axis theorem, Iz prime equals Iz plus area multiplied by h/2 squared. Then we have the same result for Iz prime, like this. Now, let's move to the product moment of area. Product moment of area is defined as the integral of the product of distance perpendicular to two reference axes with respect to the area. Let's calculate the product moment of area Izy prime with respect to coordinate yz prime for rectangle. As the first step, dA is bdy, and the second step, we locate the centroid of small area dA, which are y bar and z bar. Their coordinates are y and b/2 respectively. And in the third step, dizy prime can be expressed by y b/2 bdy. In fourth step, we integrate a small moment of area dizy prime to have b to the 2 h to the 2 over 4. Of course, we can use the small strip parallel to y prime axis. As the first step, dA is hdz. In the second step, we locate the centroid of small area dA, which are y bar and z bar. Their coordinates are z and h/2 respectively. In the third step, dizy prime can be expressed z h/2 hdz. In the fourth step, we integrate dizy prime to have b to the 2 h to the 2 over 4. This result is the exactly same as that before. What happens if y prime axis move to the left, like in this picture? As the first step, dA is bdy. In the second step, we locate the centroid of a small area dA. Their coordinates are y and minus b/2 respectively. Z bar coordinate is different from the previous one. In the third step, dizy prime can be expressed minus y b/2 bdy. In the fourth step, we integrate dizy prime to have minus b to the 2 h to the 2 over 4. Therefore, sense goes different compared with previous coordinate. We expected this result because the coordinates of every point in the rectangle have their sense plus in y-axis minus in z-axis, like this. What happens when the origin of coordinates locates at the centroid of a rectangle? At the first step, dA is bdy. In the second step, we locate the centroid of a small area dA, which is y bar and z bar. They are y and 0 respectively. Therefore, in the third step, dizy prime equals to 0. In the fourth step, we have nothing to integrate. Therefore, result is 0. What happens? Z-axis moves down to Z prime axis. and the y prime axis pass through the centroid of a rectangle. dA is the same. Y bar equals y, but z bar equals 0. Therefore, small second moment of area di zy prime equals 0. Consequently, izy prime equals 0 because we have nothing to integrate. What happens? The y-axis moves to right to y prime axis, and the z-axis passes through the centroid of a rectangle. In the same way as that in the previous slide, dizy prime equals 0 because y bar equals 0 this time. Therefore, izy prime also equals 0. Let's look into the relationship between cross-section shape and the product moment of area. Upper pictures shows the cases for zero product moment of area, and the lower pictures shows those of non-zero values. Therefore, we can conclude if a cross-section area is symmetric with respect to one of the coordinate axes, product moment of area equals 0. But be careful. At this rectangular, the width b doesn't equal to length h. This is not a square. In the square shape, the width b equals height h. Then, the area of every quadrant is all the same. That means area A, P, C, and D are the same. Moreover, the sense of product moment of area are plus in the first and the third quadrant and minus in the second and the fourth quadrant. Therefore, sum of product moment of area equals 0, regardless of the degree of rotation. As a result, we can conclude that if a cross-section is square and the coordinate origin locates at the centroid, product moment of area equals 0. In the rectangles, the length of the width doesn't equal that of the height. As you can see, the product moment of area has positive in the first and the third quadrant. On the other hand, it is negative in the second and the fourth quadrant. The areas of every quadrant are all the same only when the width and the height are parallel to the coordinate axis. Only at this case, product moment of area equals 0. In the other cases, the sum of area per first and third quadrant goes different from that of area for second and fourth quadrant. Consequently, product moment of area doesn't equal 0. Referring to the third picture, we can intuitively know that absolute value of the product moment of area reaches its maximum when the rotation angle is 45 degrees, because sum of area A and T is much different from that of B and C. This can be theoretically proved in the upcoming videos related to principal axis and the Morse circle. This picture shows the second and the product moment of area for different coordinate systems. The first case shows coordinate origin is at the centroid. The denominator is the same for two axes, and the product moment area equals 0. The second case shows a vertical axis passes through the centroid, and the horizontal axis moves to the base. The second moment of area with respect to horizontal axis increases, and product moment of area still equals 0. The third case shows both of axes do not pass through the centroid. all the second moments of area increase, and the product moment of area has its own value other than 0. The answer to the quiz is number 3, 0. Here we have a summary. Steps for calculating second moment of area. Step 1. Assuming small strip parallel to the reference axis. Step 2. Calculating small second of moment of area. Step 3. Integrating small second moment of area. In the steps for calculating product moment of area, we need one more step, which is step 2, locating centroid of a small strip. A parallel axis theorem tells us that the second moment of area with respect to the given axis is the sum of second moment of area with respect to the axis passing through the centroid parallel to the given axis, and area multiplied by the perpendicular distance squared between the axes. For the product moment of area, the distance squared is replaced by the product of perpendicular distances between parallel axes. Product moment of area is defined as integral of the product of distances perpendicular to two reference axes with respect to the area. If a cross-section area is symmetric with respect to one of coordinate axes, product moment of area equals 0. If a cross-section is square and the coordinate origin locates at the centroid, product moment of area equals 0. If you watch the previous videos, you can easily understand upcoming videos. In the previous video, E39, I explained how the unsymmetrical tire tread block produces the force per ply steer. Recently, I explained the first and the second moment of area, and also I explained why we call them first and the second moment of area. The next video is ply steer part 15, moment of area, part 3. I will explain the second moment of area for a triangle and the polar moment of area. Please hit the thumbs up and catch the brand new videos by free subscription. So, what are you waiting for? See you on next video. Goodbye guys.